You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Was the WOW signal alien? It was August 15th, 1977, when astronomer Jerry Ehrman was examining data coming from Ohio State University's radio telescope, which was engaged in listening for signals from deep space, hoping to find something of intelligent origin. In a moment that's since become one of the most famous events in astronomy, he saw a sequence of 6 characters on the printout, 6EQUJ5, which caught his attention. So much so, in fact, that he circled the text and wrote "Wow" in the margin. It was, apparently, a signal from outer space. It came from the direction of Sagittarius. The strength of the signal was represented by the digits 0 through 9 and the letters A through Z, a scale of 36 levels of intensity, rising with 6EQ and falling with UJ5, a near-perfect bell curve of signal strength spread over 72 seconds. All speculation and hype aside, WOW remains the strongest candidate ever detected for an alien radio transmission. SETI stands for the Search for Extraterrestrial Intelligence, but there's no single SETI group. For a long time, many different organizations have engaged in their own searches, but there's no central authoritative project. Virtually every radio telescope is used at least part-time by some group scanning the skies looking for signals that might come from some interstellar source. The longest single search project was carried out by Ohio State University from 1972 to 1997. When you hear about the WOW signal, one of the most important and obvious questions to ask is where it came from and what's there. To understand where the signal came from, and at least as importantly, how we know where it came from, it's necessary to understand the workings of the interesting radio telescope that received it. Ohio State's Big Ear telescope was, well, big. The telescope no longer exists, having been disassembled in 1998, and its acreage used to expand a neighboring golf course. Its main feature was a vast aluminum ground plane, 150 meters by 85 meters, about 3 times the area of an average professional soccer pitch, and aligned north-south. Near the middle of its north end were a pair of receiving horns, looking like giant foghorns pointing south. They were at the focus of a great paraboloid reflector, 110 meters by 21 meters, standing across the southern end like a giant curved movie screen. This reflector received the signal bouncing off a tiltable flat reflector spanning the north end, just beyond the receiving horns, 104 meters by 30 meters. As the Earth rotated, the Big Ear swept the sky in a single line. After a few days of data gathering, the flat reflector could be tilted a tiny bit, moving that line of study up or down across the sky. It had a total tilting range of 50 degrees. The Big Ear's design was called a Krauss telescope, after Ohio State's Dr. John Krauss, who designed it and came up with its $250,000 cost, including a $71,000 grant from the National Science Foundation. It was built by the students. In 1980, a feature was added to the Big Ear that could have come in very handy when the WOW signal was detected, and that was a set of tracks upon which the receiving horns could move east or west across the face of the flat reflector. This allowed the telescope to fix its view on the sky at any given point when an interesting signal was detected, compensating for the movement of the Earth's rotation and allowing a single spot to be studied for a time. Critically, this feature was not yet installed in 1977, so the telescope swept across the WOW signal for the duration of its detection. It took 72 seconds for the Earth's rotation to move any given point in the sky across the Big Ear's reflectors, and that's why the recorded portion of the WOW signal was 72 seconds long. In 1977, there was no automated computer analysis of the Big Ear's recordings. Its data was printed out on paper, and volunteers looked it over manually. This is what Jerry Ehrman was doing when he saw the data, circled it, and wrote "Wow." The Big Ear would alternate recording between the 2 receiving horns. Subtracting the signal from one horn from that of the other was a way to identify and reduce noise in the signal. This cleaned-up signal is what got recorded. The horns were physically right beside each other, so each was focused on a slightly different position in the sky, about 2 minutes apart, by the speed at which the sky rotates past. It's known that the wow signal was audible to only one of the two horns, but there was no way to tell which one because of the way the signal was recorded. The wow source either started or stopped inside the time gap between the two horns, and lasted less than 24 hours, since it was not detected at that same declination either the day before or the day after. So it's not known how long the signal actually lasted, somewhere between 72 seconds and 24 hours. When you look at a star map showing the location of WOW's origin, you see two little line segments, one from where each horn was recording at the time. These little dashes are in a part of the sky where there's nothing of much interest. No close stars, no other radio sources, just, well, space. There's nothing obvious there to listen for, but nevertheless, astronomers have on many, many occasions pointed telescopes at WOW's origin, hoping to hear it again, but nobody has ever heard even the slightest blip. Whatever WOW was, it was transient. Try as we might, we've never been able to find it again in over 100 different attempts. So another question to which we might want to know the answer is, what was interesting about the WOW signal? Obviously, there are many different types of radio signals bouncing around space all the time, so how do we know that there was anything special or unusual about this one? The solution to this lies in the signal's frequency. To understand why the WOW frequency was noteworthy, we have to know a little about the cosmic radio environment. There are different kinds of noise in different parts of the radio spectrum. Throughout the radio spectrum, there's a background level of about 3 kelvins, representing the leftover noise from the Big Bang. So that 3 Kelvin level is the quietest window we might hope to find. Below about 1 gigahertz, there's a lot of galactic noise, making it hard for an artificial signal to compete. And above about 10 gigahertz, something called quantum noise, in a nutshell, the uncertainty of photonic measurements, becomes too great to listen through. So we have a relatively quiet window between 1 and 10 gigahertz. Not only is there noise at different frequencies, but planetary atmospheres like Earth's block out a lot of different chunks of the spectrum, absorbing some of it and reflecting others. There are 2 great windows through which our atmosphere is more or less transparent to electromagnetic radiation. First is the visible spectrum, which is why our eyes evolved to see at the frequencies they do. Second is, coincidentally, that very same 1 to 10 gigahertz gap. So if you're an intelligent alien, and you want to attract the attention of another intelligent alien, you're going to try and do it on a frequency which, for one, is likely to be heard, and for another, is likely to be easily identifiable as artificial. So you're probably going to want to send your signal on a frequency that makes it through an atmosphere, and where there's a minimum of competing background noise, and, for extra measure, is right near the most universally recognized frequency of all, that of hydrogen, the universe's most abundant element. Interstellar hydrogen precesses at 1.42 gigahertz. Precession can be thought of as the way a proton wobbles as it spins. The unfathomably massive quantities of interstellar hydrogen out there means that all that precession can actually be heard by sensitive radio receivers tuned to 1.42 gigahertz. Nearby on the spectrum is the frequency of interstellar hydroxyl, precessing at 1.66 gigahertz. We can see these 2 spikes when we look at the signal received by a radio transmitter pointed at any quiet region of space. In fact, any radio telescope anywhere in the galaxy will see exactly the same thing. Astronomers call this frequency band the water hole for 2 very good reasons. First, hydrogen and hydroxyl are the dissociation products of water, the best environment for life. Second, these signposts are universal and would be recognized by any civilization anywhere. And so, like the water cooler at the office that draws a crowd, the water hole is nature's gathering point on the radio spectrum, a blatantly obvious place for interstellar communities to meet and greet. The WOW signal was squarely in the middle of the water hole at 1.42 gigahertz. It was the perfect storm of intelligent interstellar radio signals. If we ever do receive a deliberate alien transmission, wow was exactly what we'd hope and expect to find. Wow has tantalized by evading almost every suggestion put forth to explain it. For one reason, that frequency range is protected. Nobody on Earth is allowed to transmit on that frequency. We know the signal did not come from an aircraft or spacecraft passing overhead, because the signal was consistent with a point in the sky that was not moving. No known planets or asteroids were in a position that they could have reflected the signal toward Earth. Any space debris would have had to be absolutely still in space relative to the big ear, which is unlikely, and not tumbling, which is also unlikely. Even complicated astronomical effects like gravitational lensing and interstellar scintillation, basically twinkling like that which we observe stars doing visually, have technical reasons that make them very poor candidates to explain wow. A radio transmission from a point in space in the direction of Sagittarius still remains the best technical explanation for wow. Jerry Ehrman, the astronomer who found the signal, has written that he chooses not to draw vast conclusions from half-vast data. In conclusion, yes, an alien intelligence is still a candidate explanation for the wow signal. But there's no evidence for this. A stronger candidate is the significantly more vague explanation of an interstellar radio source of unknown origin. Meanwhile, Jerry Ehrman's famous scrap of printout with his famous handwriting rests in the archives of the Ohio Historical Society. In these days of manufactured mysteries and sensationalized nonsense, wow remains the genuine article, a true mystery, with potential implications unlike anything else in history. It's quite possibly one of the most exciting unsolved mysteries that we have, and it lies quietly in the North American Astrophysical Observatory records with call number MSS 1151. Someday, someone will probably solve it. That's a treasure hunt worth waiting for. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.